I'm Joey Echeverria. I'm Rocana's Director of Engineering. Today I'm going to be talking about Dr. Syslog, or how I learned to stop worrying and love big data. Really what I'm going to be talking about is how Rocana uses big data to tackle IT operations analytics. So let's do a quick tour of the Rocana ops architecture. So Rocana is based around the concept of trying to get all of your operational data into a single event data warehouse. We do that with data collection. The first question people often ask us is, what types of data can you collect? We can do Syslog, we can capture application logs, web server logs, database logs, metrics, SIEM events from your ArcSight or other tools like that, APM feeds. What about other types of data? You didn't list my specific data source there. We've got an API for that. So we've got a REST API so you can send log data in, as well as a native Java SDK so that you can instrument your applications that way. So what do we do with that data? How do we handle that? And the first question that comes in this portion is, how much data can you actually handle? You talk about big data, but what does that mean to you? Our answer is usually, how much data do you have? It could be 500 gigabytes, 100 gigabytes, 10 terabytes per day. We don't care. We built this on top of a big data platform so we get that scalability for free. And all of this information is brought together in what we call this event data warehouse, so that you can then analyze it in a unified way. No longer do you have to decide, what do I keep or how long do I keep it? You just get to collect all of your IT operational data, bring it into a single platform, and use it for solving and reducing the time to find root cause of your operational problems. So real quick, I'm going to go through some 3 case studies. One of our customers is a large financial services company. They really wanted to be able to grow the top line of their business and address churn in their web properties. In order to do this, they needed to aggregate logs from many different systems. They needed reliable connection. They couldn't handle losing large chunks of data, and they needed it from geographically remote sites. We put Rocana Ops in place. We installed our data collection agent across a large number of machines. We collected that all into a single Hadoop cluster. And the result was they gained a single source of truth for their IT operational data. They no longer had to go to different silos. They no longer had to just pick and choose what they were looking at. We also reduced the mean time to resolution for their tickets. So now when issues cropped up in the enterprise, because they're not hunting from system to system to get the data they need, they're able to do everything in a single platform, and that saves them time. Lastly, it allows them to deliver a better customer experience to their users. And that's really what we're trying to do. The reason why you do IT operations is not just to keep IT systems up for the fun of it. It's because you actually are delivering values and results to your end users. In particular, they were able to consolidate multiple IT operational monitoring solutions into a single one at a scale of more than 1 terabyte of data ingest per day. The next case study is a big box retailer. Their challenge was to improve the security posture given the more modern scalable solutions that they were deploying in their data center. So they again needed lossless data collection from many remote sites. They needed to make sure they were getting all of the security relevant data into their system. And the end results was that we had very low overhead of collection. So we make use of Apache Kafka for our event data bus. And that gives us the ability to scale up reliable data transport from across the enterprise with a very low overhead. So despite the fact that we handle huge throughput, 1 terabyte, 10 terabytes of data per day, we're able to do that while still maintaining low latency. And then they also get fast direct access, not just from our platform, but we store all of the data in the event data warehouse in open formats. So we make use of Apache Parquet and Apache Avro, so that any data that's stored on the system is accessible not just in our application, but in other tools. We take the view that you own the data. We're going to provide you capabilities to collect it and to perform analytics and searches on top of it. But ultimately, you need to do other things with that data as well, and it's not ours to control what that is. And in this particular case, they were able to scale up to 3.5 terabytes of data ingest per day and retain over a petabyte of data per year. with all of that data being searchable. So this isn't a matter of technically you kept all of the data, but then you had to throw away and get less capability over some of it. We maintain all of the searchability of the data throughout the historical archive. The last case study I'm going to talk to you today is an international gaming company. Game companies have one of the most complex architectures. If you think about it, they were the Internet of Things before anyone talked about the Internet of Things. All of the games out there are sensors that are producing data. They need to get that information, and they have real tangible results. If you're able to optimize the network path of a user of your game, you're able to increase the attach rate, and you're able to improve your revenue stream. And their requirements are to scale to millions of users. They also have lossless data collection as a requirement. This comes up a lot. And they needed that data available for analysis in real time. The end result was that they were actually able to improve the gameplay of their users. One of the things in particular that they did is they optimized the network paths that users would take to reach them. So they could actually tell on a per user basis which network path they were taking, and they could talk to those network operators and say, hey, I found a problem in your network. If you do this, it'll send them to a faster server. That improved their ability to enhance revenue because it increased the attach rate. It increased how much people kept coming back to the game. And it also improved their ability to monitor security events. The first day that we installed our application and their infrastructure, we actually found a server that was misconfigured and was having an active SSH attack going against it. And that was just the very first day that we installed the POC. So they were able to quickly get that server patched, close the port, and reduce any risk of someone getting into their servers. I think that's a repeat. And they're scaling beyond even what we've done with our other customers. So they're pushing closer to 30 terabytes per day of ingest and more than 1 petabyte per year of data retention. And again, that data will be available immediately and at their fingertips. All right, I'm going to go and switch over to a very brief demo. Let's see if this shows up here correctly. So this is Rocana Ops. It probably looks similar to a lot of other IT monitoring tools. On the home page, let me see if I can get this to fit a little bit better. There we go. On the home page, we're giving you a snapshot of your overall infrastructure. So that's everything that's there on the left. Gives you an event count by different types of data sources. So the way that we break up events is by 3 common attributes: a location for where that data came from, the host where the data was generated, and the service that generated the data. And then we're also giving you a snapshot of the distribution of change across those. So we can see that in this particular case, the data is actually pretty steady. There's not a lot of churn going on. But there were a couple of locations that actually showed a greater than 80% change in just the earlier today. We can do the same thing by host and by service. We also have built-in anomaly detection. So we will look at your data profile, build historical models for what is typical, and then alert you to the fact that anomalous behavior is happening on your system. So if I go to the search view and look in the last day, I'll see some interesting events here. So these are the same anomalies that we were seeing on the home page, but now built up against a histogram of your data. And so if I zoom in here, I can see that all of this extra data is coming from a single location. Let me change the facets that I'm breaking things down by. Don't get anything interesting there. If I come over to services, suddenly I can see a huge jump in one of the services, namely Regulus. So I can go ahead and turn everything off here and tune just that one source. And then I can go in deep. I can go in deep in one of these end results, and I see that I'm getting an error message in my Regulus log that the configuration file is missing. So clearly something has happened that caused the config file to no longer be there, and that's something that I can address very quickly with my system. All right, thank you very much.